Why do we say that only one circle can pass through three non-collinear points? To know why this is the case, we need to understand another simple concept. This is a segment AB and this is a line L, which is its perpendicular bisector. Since line L is a perpendicular bisector, it will be perpendicular to AB and both parts of the segment will be equal to each other. Now consider a point R anywhere on the perpendicular bisector. The distance at this point from the endpoints of the segment will always be equal. It means AR will always be equal to BR. That's the beauty of perpendicular bisectors. Similarly, if we have a point Q, then AQ will be equal to BQ. Or if we have a point S here, AS will be equal to BS. This is called the perpendicular bisector theorem. We can use this theorem to prove that only one circle passes through three non-collinear points. The proof is really simple. Consider these three non-collinear points A, B and C. That is the data that has been given to us. These 3 points are non-collinear. And we have to prove that one and only one circle can be drawn through these 3 points. Before we move on to the proof, let's analyze how do we aim to prove it. How can we prove that only one circle passes through points A, B and C? Let me give you a hint. Let's assume we have a point O somewhere on the same plane as these 3 points. If we successfully prove that OA will be equal to OB, which will be equal to OC, then we will be able to say that one circle passes through points A, B and C. Because all 3 segments OA, OB and OC will be the radii of the circle. But how do we get this point O is the question. We will need to do a bit of construction for that. First, let's draw line segments AB and BC. We join A and B and points B and C. That was the first step of our construction. To get point O, we can draw the perpendicular bisectors of segments AB and BC. Let line L be the perpendicular bisector of AB. So this angle will be a right angle and these 2 parts of AB will be equal. And let line M be the perpendicular bisector of segment BC. Let these 2 perpendicular bisectors meet at point O. These were the 2 steps in our construction. First, we joined AB and BC, and next, we drew their perpendicular bisectors. Now we just need to prove that OA, OB and OC are equal. We can prove this in just 2 steps. We know that line L is the perpendicular bisector of AB, and since point O lies on line L, OA will be equal to OB by the perpendicular bisector theorem. Let this be our first equation. And similarly, since point O lies on line M, using the perpendicular bisector theorem, OB will be equal to OC. Let this be our second equation. We get these 2 equations using the perpendicular bisector theorem. That's it. It's almost proved. Look at these 2 equations. OA is equal to OB and OB in turn is equal to OC. What does that tell us? Yes, all 3 are equal to each other. From equations 1 and 2, we can say that OA is equal to OB is equal to OC. That's exactly what we wanted. Let them be equal to the radius r. This will be a circle with radius r that passes through points A, B and C. The theorem says that if we have 3 non-collinear points, there will be exactly one circle which passes through all of them. There's another tiny little thing we can derive using this theorem. Look at this random triangle. We know that it has 3 vertices. Using the theorem we just learnt, we can say that there will always be just one circle which passes through all its vertices. This circle, which passes through all the vertices, is called the circumcircle of the triangle.